fast can I explain the basics of electrical engineering? We're about to find out. So we'll start with Coulomb's law, which is an electromagnetism topic that deals with point charges. I have a few facts about point charges listed here, but I really want you to focus on these last two, which say that opposite charges attract each other and like charges repel each other. So we have a 200 times 10 to the negative 6 Coulomb charge on each of these point charges. There's also a 10-meter distance between these two. Now, when it comes to Coulomb's law, we actually don't care about the signs on each of the two charges. We only care about the direction. Any vector that travels to the left, we generally denote that as being the negative direction, and to the right, we typically have that be the positive direction. If we have these two charges here, we're trying to focus on the net force of the right point charge, which is this positive charge. So since we know that opposite charges attract each other, we know these are going to feel a force of attraction towards each other. So we already know the direction this charge is going to travel. We just need to figure out the magnitude. This is Coulomb's law, which is your force is going to equal K times charge 1 times charge 2 over R squared. And K is this constant value right here. So if you take this constant value and you plug it in for K, all you need to do is take your 2 point charges and plug them in right here, and then take your distance and plug it in for R, and this will give you this equation right here. Now all you need to do is evaluate this either on a calculator or by hand, and you should get that your force is 3.6 times 10 to the negative 6 newtons. But remember, we're focusing on the right point charge, which is the positive one, and that point charge is traveling to the left, so we need to make this value negative. So negative 3.6 times 10 to the negative 6 newtons is the answer to this problem. Now let's try solving a capacitor circuit. Now the capacitors are measured in microfarads, so just keep that in mind. So in this case, you need to know the two equations that when dealing with capacitor circuits, when we have capacitors in series and parallel capacitors. So you use this equation when you're dealing with series capacitors, and this equation when dealing with parallel capacitors. Now the first thing that I notice is we have two parallel capacitors right here. So in this case, we can use the parallel equation. And since we only have two capacitors, I'm only going to account for two capacitors in this equation. So we have the 3 microfarad capacitor and the 5 microfarad capacitor. So we have 3 plus 5, which will give us 8 microfarads. So we can take these two capacitors right here and combine it into a single 8 microfarad capacitor. Now we have two capacitors in series. So I'm going to go ahead and use the series equation, which looks like this. Again, we only have two capacitors here, and so I just need to take the 8 microfarads from here and the 8 from here and plug it into this bottom equation. We should get this right here. Now if you evaluate this equation, raise it to the negative first power, don't forget about that, you should get 4. So you get this, and now you have the total voltage right here, which is just the battery, and the total capacitance on your circuit. The only thing we need now is the charge, and we can calculate the charge using this equation, which is charge is equal to capacitance times voltage. So we take our voltage and capacitance, plug it into this equation, and if we have 4 microfarads times 20 volts, we should get 80 microcoulombs. So that's your total charge, total voltage, and total capacitance on this circuit. Now, here's a quick crib sheet that just covers all the equations we went over in this video, and I also included equations for a resistor circuit. So that right there is a basic introduction to electrical engineering.